a factor, a number. So Q is called the quality factor. I have to calculate self-inductance of the circuit. F0 turns out to be 32 Hertz. This is the common data that is given in the exam. I need to calculate resonant frequency. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Hope you people have practiced the problems done in the previous session. By now, you should have got a flavor, an instinct to solve the problems. Again, now and then, I often quote question number 35 in the question paper is basically problems from this chapter. So I expect you all to keep on practicing the problems, follow the sessions, take out previous question papers. So very clearly you will understand they are all problems from those papers. Now continuing my discussion on the problems, the next one, quite interesting. So the problems that we solve in today's class are quite interesting. The problem says a resistor, an inductor and a capacitor ಮೂರು ಕಾಂಪೊನೆಂಟ್ಗಳಿದೆ. resistor, inductor and a capacitor are connected with 220 volts 100 Hertz AC source. So the VRMS value now is 120 volt. Frequency is 100 Hertz. Very clearly now the problem says voltage leads current by 35 degrees in the circuit. Voltage is leading current. Inductor dominated circuit. So voltage leads current by 35 degrees. Now comes the best part. He says, if the resistance of the resistor is 10 ohms, resistance of the resistor is 10 ohms, and the sum of inductive and capacitive reactance is 17 ohms. Resistance in the circuit is 10 ohms. The sum of inductive and capacitive reactance is 17 ohms. I have to calculate the self-inductance of the inductor. A very interesting problem. ಕೊಟ್ಟಿರುವ AC ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಇಂಡಕ್ಟರು ಇದೆ, ಕೆಪಾಸಿಟರು ಇದೆ, and there is a resistor. They are connected to a source of alternating voltage 120 volts 100 hertz. So the first data I get is VRMS value, which is 120 volts now, and frequency is 100 hertz. ಎಲ್ಲೋ ಕೆನಡಾದಲ್ಲೋ US ಎಲ್ಲೋ ರೇಟಿಂಗ್ ತಗೊಂಡಿದ್ದಾರೆ, because in India alternating frequency is always 50 hertz. Voltage leads current by 35 degrees. The phase angle is 35 degrees. Voltage is leading current by an angle 35 degrees in the circuit. Resistance is 10 ohms. So this is the basic data I have. VRMS 120 volts, frequency 100 hertz, phase angle 35 degrees, or resistance 10 ohms. But the epitome of solution, the major hint that is given is sum of inductive and capacitive reactance is 17 ohms. Inductive reactance is XL plus capacitive reactance is XC. This turns out to be 17 ohms, and this is the classical hint that is given. Now follow carefully. How will I solve? With this data, I have to calculate self-inductance of the circuit. So this problem says XL plus XC is 17 ohms, with which I have to calculate the value of L. How do I proceed? See, I know XL is 2 pi F into L. F is given 100 hertz. If anywhere I am able to calculate XL, it becomes a direct substitution from which I can calculate inductance. Now, I know that tan phi is XL minus XC by R. Why did I pick up this equation? See, XL minus XC there. I have to start thinking that way. XL plus XC there. Two simultaneous equations I get from which XL can be calculated. So here, XL minus XC is tan 35 degrees into 10. Resistance is 10 ohms. Phi is 35 degrees. Look for your logbooks. Tan 35 estunt node into 10. So XL minus XC turns out to be 7 ohms. Now I have two simultaneous equations. XL plus XC is 17. XL minus XC is 7, from which XL is 12 ohms. Now I know XL is 2 pi F into L. Substituting here, L turns out to be 19 millihenries. So in simple, the only hint I extracted from the problem is sum of the inductive and capacitive reactances being 17 ohms. So to calculate L, somehow I had to get XL. So I went for this equation so that I frame two linear equations. Simplify, L turns out to be 19 millihenry. The next one, again a simple one. A series LCR circuit is connected to 220 volt AC source of variable frequency. ಇಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಸಪ್ಲೈ ಆಗ್ತಿಲ್ಲ, ವೇರಿಯೇಬಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. So there is a series LCR AC circuit which is connected to 220 volt AC source. So very clearly I am getting my VRMS value, which is 220 volt, variable frequency. The inductance of the coil is 5 Henry. The capacitance of the coil is 5 microfarad. And resistance is 40 ohms. Inductance ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 5 Henry. Capacitance ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 5 microfarad. Resistance ಎಷ್ಟಿದೆ? 40 ohms. Now, at resonance, the key feature, at resonance, calculate resonant frequency, current in the circuit, inductive reactance. So first one, resonant frequency, F naught equals 1 by 2 pi root LC. Please do see that you are familiar with the expressions. The expression for resonant frequency, probably any multiple number of times I have used. The moment you see L, the moment you see capacitance in the data, resonant frequency equals 1 by 2 pi root LC. or F naught is 1 by 2 pi root the value of L, which is 5 Henry. So 5 into 5 microfarads, 10 power minus 6. Take out your calculators. Do the substitution. F naught turns out to be nearly 32 hertz. Simple substitution. Istu madidre 2 marks is already in your pocket. What is the great difficulty here? Knowing the expression F naught equals 1 by 2 pi root LC. Collect the data from the problem, substitute, simplify, F naught turns out to be 32 hertz. B, current in the circuit. So I is equal to, or IRMS is equal to VRMS by Z. Again, what is Z? If you have attempted the first session, very clearly here, the problem is saying at resonance. So at resonance, Z is always equal to R. I had highlighted this point. So at resonance, Z equals R, a trivial concept. So IRMS is 220 divided by, now what is the value of R? It is 40. So 22 by 4, 11 by 2, 5.5 amperes. So see, easily I have arrived at the current flowing through the circuit. And finally, inductive reactance XL is 2 pi FL. Now, this F takes out to be F naught because the circuit is in resonance. So 2 into 3.14 into 32 into L is 5. So when I simplify, here we have 2 into 3.14 into 32 into 5. So nearly 1000 ohms. See? I need not scratch my head, students, to score a 5 marker here. Simple concepts, simple formulas will easily yield me a 5 marker. Next one. A resistance of 50 ohms and an inductance of 10 millihenry. Resistance of 50 ohms, inductance of 10 millihenry, and capacitance of 20 microfarad are connected in series again to 220 volts, 50 hertz AC source. I have to calculate current in the circuit and the power factor. So again, the data says VRMS is 220 volt. Frequency is 50 hertz. This is the common data that is given in the exam. The first thing, as I told, what is that you will look on to? The applied voltage, applied EMF, which is called the RMS value. Now resistance is 50 ohms. Inductance is 10 millihenry and capacitance is 20 microfarad. So I have collected all the data possible from the question. So the first thing I need to calculate is current in the circuit. Andreno, IRMS value of the current, for which I need to calculate impedance. So what did I say? In order to calculate impedance, I will have to calculate XL and XC. The same steps in this chapter. XL, XC, impedance, current. So XL is 2 pi FL 2 into 3.14 into 50 into L is 10 millihenry. So on calculation, so this is 2 into 3.14 into 50 into 10, which is 3140 into 10 power minus 3. 1, 2, 3. So this is 3.14 ohms. So I have got XL. See, very simple. It is 2 into 3.14 into 50 into 10 millihenries, 3.14 ohms. Next, I will calculate XC, which is 1 by 2 pi FC. This is 1 by 2 into 3.14 into 50 into the value of capacitance, which is 20 microfarad. So 20 into 10 power minus 6. So this is 10 power minus 6 goes to the numerator, plus 6 into 3.14 into 50 into 20 is 6280. So this is 1 divided by 6280. So 6 places I shift. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So nearly 159 ohms. 1 mark for the calculation of XL, 1 mark for the calculation of XC. Now impedance. All of us know. So Z is root of R square plus, since XC is greater than XL, XE minus XL whole square. Or this is, so what is the value of R given? R turns out to be 50 ohms. 50 square plus 159 minus 3, 156 whole square. So many ohms will be the impedance. Simplification task for y'all. Now, again very simple. IRMS is VRMS by Z. Again substitute so many amps. And finally, power factor cos phi is R by Z. So you observe simple calculations, simple manipulations, we are arriving at the answers. Next one. This is quite interesting again. Calculate the resonant frequency. Again, resonant frequency of a series LCR circuit with inductance 4 Henry, capacitance 64 microfarad and resistance 20 ohms. Inductance is 4 Henry, capacitance 64 microfarad, resistance 20 ohms. With this, I need to calculate resonant frequency. And also, I need to calculate the Q value, quality factor for the circuit. Now again, the data says L is 4 Henries, capacitance is 64 into 10 power minus 6 farad, resistance is 20 ohms. First we will calculate the resonant frequency. Omega naught is 1 by root of LC. Idenappa idu? Previously, resonant frequency F naught ant baradubuttu 1 by 2 pi root LC ant baradru. Here resonant frequency is omega naught, which is 1 by root LC. You can also calculate angular resonant frequency. ದಯವಿಟ್ಟು ನೆನಪಿಟ್ಕೊಳ್ಳಿ, where you are asked to calculate quality factor along with resonant frequency, use this expression to calculate resonant frequency. Omega naught is 1 by root LC. F naught agidre 2 pi bandirodu. This is angular resonant frequency. So on substitution, so this is 1 by root of, again L is 4 and 64. 4 into 64 into 10 power minus 6. and omega naught is 62.5 radian per second. So I have calculated the resonant frequency here. With this, I need to calculate quality factor. Please know, quality factor is omega naught L divided by R. Therefore, I have used this expression. Quality factor ಕೇಳಲಿಲ್ಲ ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹಾಕೊಳ್ಳಿ, ಅಥವಾ ಇಟ್ಸ್ ಸ್ಟಿಲ್ tedious ಅಲ್ಲಿ ಎಫ್ ನಾಟ್ ಹಾಕೊಂಡು 2 pi f naught into L by R ಅದು ಮಾಡಿದ್ದೀವಿ. So I am showing one more method to calculate quality factor. So 62.5 into 4 divided by R, where R is 20, and this turns out to be 12.5. Does it have an unit? No, it is simply a factor, a number. So Q is called the quality factor. Again, quite interesting. Now, a 1 by 12 pi millifarad capacitor is in series with 40 ohms resistance connected to 110 volt 60 hertz supply. First, I have to calculate maximum current in the circuit, then phase difference between maximum current and maximum voltage. Again, capacitance is 1 by 12 pi millifarad. We have resistance of 40 ohms. We have VRMS of 110 volts, frequency of 60 hertz. Now this is not simply current. I want maximum current, for which again, as I have done in all my previous problems, first XC calculate marana. Quite interesting calculation. 1 by 2 pi FC. So XC will be 1 by 2 pi. Now what is the value of F? 60 into the capacitance is 1 by 12 pi milli minus 3 nallide. So pi and pi gets cancelled. 2 goes 6 times, 10 times. So XC is minus 3 male hodaga divided by 10. So which is 10 power 2, which is 100 ohms. So I have calculated XC, which is 100 ohms. Now impedance is root R square plus XC whole square, root 40 square plus 100 square. So this turns out to be 107 ohms. What is next? Very good. IRMS, which is VRMS by Z. The value of VRMS is 110. So 110 by Z is 107, which is nearly some 1 point or 1 ampere. Now with this IRMS, how will I calculate maximum current? We know IRMS is I naught by root 2. Again, please know this. See, to calculate any specification, the first 3 steps, calculation of respective reactances, impedances, IRMS holds good. So here, I naught is IRMS into root 2. So 1 into 1.41, which is 1.41 amps. Now with all these things, you have to calculate the phase between maximum current and voltage. So we have tan phi equals XL minus XC by R, but this is only XC by R. When you substitute, 68 degrees will be the answer. So students, very clearly again, I have worked out problems which are superficially important. Practice this again. Make yourself thorough. Get that 5 marks with the 35th question. Next, I come up with problems on EMI. Until then, have a nice time. Thank you.